Okay, everyone, thanks for waiting patiently. We're going to start the webinar. Thank you so much for joining us. And with us today, we have David Wickett, Director of Pre-Sales at DSI. So I'll hand it over to David. Hi, David.
Hi. Thanks, everybody, for coming and sharing your lunch hour with me. What I want to do over the next hour is to discuss the modern analytics platform. So what I'm going to do is help you map your future and indicate how this platform can be used for growth and change. So we're from Dimensional Strategies, Inc. We're an IT service provider. We've got 20 years experience in analytics and business intelligence. We focus predominantly on the Microsoft platform as from about 2008 till currently. We do extensive amount of work in the SQL BI stack as well as many of the Azure services that are out there. So the objectives of this call is to first understand the three principles of modern data analytics in terms of understanding, what are the drivers behind modern data analytics. And once we have an understanding of what those three principles are, we want to provide a roadmap towards modern analytics. So my background is as a chartered accountant, so I'm very much functionally oriented. So I get a little bit frustrated when I see a lot of the technical documents and you can do this, here's all these technical solutions or technical approaches, shall I say, but a lot of them don't kind of frame themselves in an overall solution. Is how do we use all these great tools in a cohesive way and still stay within the overall governance model of an IT environment. So I'm going to be looking at it a bit more from a functional architectural approach and not purely from a technical direction. There's a lot of data out there. We deal with a lot of corporate data in most of our implementations at DSI. So what I want to do is I want to focus on corporate and business reporting strategy, where data governance and security is critical. But I'm not going to provide a solution that's going to solve every single data problem that exists within the organization. This is really focused, like I said, around that corporate reporting. And what we're doing is really provided a foundation to build upon. I'm not going to provide you with an out-of-box solution. We can go there and install something, everything's good to go. This is a roadmap and a journey that you'll have to work through and customize yourself, but what I want to try to do is provide a foundation and framework for moving your analytics environment forward. So what we're going to cover today is we're going to kind of go through how we got to where we are. So a bit of a history of analytics. We're going to talk about the three principles of modern data analytics. We're going to discuss how the traditional analytics approach can only take us so far. And then what we're going to do is we're going to kind of get through those three principles. We're going to look at how we deal with velocity of change, how we apply data governance security to that, how we deal with volumes of data, and how we deal with a variety of data sources. And like Amanda said, if you have any questions, I'd rather answer the questions within context of what I'm presenting than try to answer them all at the very end. So feel free to add anything to the chat window, and Amanda will let me know when something comes up, and I'll try to answer within context of what I'm actually talking about. And just to make sure that everybody's hearing us, because we haven't seen any chat traffic come through, could one or more of you just let us know that you're able to hear us properly and the chat is working? That would be much appreciated. Usually we would have had a chat by now saying we can't hear you, so I'm trusting everything's okay. So how did we get here? So way back in the 90s when business intelligence and data warehousing was really popular, that's where the traditional data warehouse approach really originated, really became quite popular with the organization. But it's a very structured development environment. So you have a rigid train of requests, excuse me, in the sense that everything's going through a formal requirements process. Everybody fills out the requirements documents. They put together these formal project plans. And you go through this, basically waterfall approach in terms of building out your traditional data warehouse. Typically, there's a reliance on a small team of specialists who generate not only the underlying data structure, but responsible for all the reporting and analytics. So very much a bottleneck within the organization. And traditionally, it's been on-premise, and it's been a very centralized solution. So some of the risks with this approach, and there's obviously much more than I've listed here, but predominantly there's a sense of alienation of the business, predominantly from a response time in terms of when they want to do a new analysis, it's like, okay, get in queue, we'll get back to you when we can. or it takes 6 weeks to get a report back. By the time the report comes back, the problem has been solved, or they've gone up and done something else. And as a result, it stifles a lot of innovation within the companies because they can't react quick enough. So what's happened over the last decade has been the introduction of a lot more modern analytical tools. So there's been a rapid growth in capabilities. I think between Power BI, Tableau, ClickView, and a dozen other tools out there, the capacity to do analytics on the front end has gone exponentially large. The first wave of tools are really enabling business users to do ad hoc analysis around the existing governed data sources. So, and that was meeting the needs of information workers, because in the past they couldn't even get data out of their existing system. So the first wave allowed people to have free ad hoc access to the data that was already existing within the traditional data warehouses. But the recent wave of tools have really continued to expand upon that capabilities. They allowed you to load and manipulate data. The individuals can analyze millions of rows of data. They can pull in disparate data sports, and they can do all this without any kind of IT support, which sounds wonderful when you look at it from an IT perspective. Okay, they're doing their own thing. I don't need to worry about them. But what's happening in a lot of these scenarios is they're actually circumventing the security and data governance policies that are out there. So as a result, I like to refer to a little bit of, Excel hell on steroids. You got this situation that occurred before data warehousing, where everybody's coming into the meeting with 4 different sales reports, and they all have 4 different numbers, and everybody's trying to argue about which number is right instead of actually having an argument about what's going on with our sales numbers. The only thing with the modern wave of tools, we're able to do that as well, but the pictures are a lot prettier. The amount of data we can consume and the data sources are all over the place, but the risk of everybody kind of doing their own analysis and coming up with their own results without any kind of data governance is very real with the modern analytical tools. So my perspective on the 3 principles of modern data analytics is a bit of a twist on the 3 V's of big data in terms of volume, variety, and velocity. So from a volume perspective, we're finding that we're getting a much finer level of detail on the transactions. So in addition to more transactions, it's a bit more of the variety side. Even the data we got, we're capturing at a much more granular level of detail, and that's really expanding the volumes of our data. And one of the challenges with that is we're finding it very difficult to project data volumes out into the future because data is growing so quickly. We have all kinds of posters around our office when they're talking about the growth of data and everything else. So I was actually at a Microsoft seminar last week, and I think they basically said that the data created in the last 2 years or some short time frame like that was more data than's been created since the beginning of mankind. And I'm sure that window of growth is going to drop to a year. It's going to drop to 6 months as we continue to bring more and more devices on board. So the ability to project your data volumes is difficult. I mean, even with your existing known ERP systems, you probably have a decent idea of that growth, but it's the new data coming in, projecting that volume data growth is very difficult to do. The variety of data sources is also occurring as well. So, you got social media feeds, you've got IoT, and you got stuff that's coming in. It's structured data, we got unstructured data. Every time you turn around a corner, somebody wants to analyze a new piece of data, or there's a new business process they want to bring in. And so that variety of data sources continue to extend exponentially. And then finally, the one I find that a lot of businesses struggle with the most is the velocity of change. So in this case, in the context of big data, this is usually a measurement in terms of how fast the data is coming into the system. From a modern data analytics perspective, it's much more about how quickly are your requirements changing, how quickly are your source systems changing. And this is what the velocity that modern data architects are really struggling to deal with. Typically the velocity in the context of corporate business transactions is usually manageable. You can fine tune and everything else, but it's a changing of requirements that's really one of the critical elements within the modern data analytics. So what we need is we need a roadmap that can help us adapt to an ever-changing landscape. We need to build a foundation for a modern analytics platform that deals with your constantly increasing volumes, your varied data sources, and your velocity of change. But while you're doing that, we want to make sure we're enforcing our security and data governance policies that we've had in place and want to continue to be in place. And some of the current trends coming up with with Europe or the EU implementing much stringent security policies around any data that you're capturing in terms of any EU citizens, I think we're actually going to see external security requirements around data protection become stronger and stronger. So I think the security and data governance policies, as we this pendulum swings back from let's give everybody every access to all the data, I think that pendulum's going to swing back, and I think IT organizations are going to need to implement much tighter security and data governance policies. And the one thing I wanted to make sure when I built this roadmap is that we were taking advantage of people's existing investments. It's great to go out there and tell everybody, okay, here's the modern platform, you need to build it and everything else, but most companies through the early part of the 21st century and the latter part of the 20th century have building up these data warehouse assets over that period of time. And there's a lot of valuable information, and there's a lot of business criticality that goes along with that. I don't want that investment to be thrown away. I think you should leverage that investment, but I think there's some things you need to do in terms of replatforming it to make it adaptable to the modern analytics platform. So those are kind of the elements that I wanted to make sure got included within my roadmap. Okay, any questions so far? We're doing okay?
Doing good.
We have some people that are actually listening?
Yes, we do. We got a great crowd today. That's great.
Good, excellent. Okay, so let's take a look at what traditional analytics is able to do for us and why it can only take us so far. So, first of all, I want to say is that traditional analytics still plays an important role in a modern analytics platform. There's still a lot of data that you want to integrate. There's a lot of great transformation rules. There's a lot of stuff you want to do with that data where really only a traditional enterprise data warehouse architecture will meet those needs. And that traditional analytics platform is going from source system, going through some sort of integration layer. If you're using Microsoft, that would be SSIS. Putting everything into a data repository, data warehouse, presenting it through some sort of semantic layer, which is typically SQL Server Analysis Services, and then consuming it for a variety of presentation tools. And the 3 from Microsoft are noted here. But the big data and the demands for advanced analytics has exposed some of those limitations. So if I take a look at what the benefits of traditional analytics are versus some of their limitations, you'll see that the same benefits that have been around since day one. We've got centralized data integration, we got managed data quality, which means we have that single source of the truth. Because reporting is centralized through a single data warehouse, we're able to support all these reporting applications. We're getting consistent data across all our applications. And if you're using a semantic model like SSAS, there's no data model required by the report consumers. You're predictating how the data will be consumed. From a business logic perspective, it's centrally managed. Again, we're getting that single source of the truth. And we're dealing with a centralized security model, so everybody's implementing the same role level security. Doesn't matter what report or access you're getting, everybody's getting access to the same slice of data that they're allowed to get access to based on your security policies. And we're leveraging Active Directory and single sign-on. On the downside, though, it's a very rigid structure. So any new data sources, any change in business logic really requires a material amount of development to integrate these new data sources into your data repository. There's no support for ad hoc data sources, and your reporting is limited to the data and the logic that's typically put into the existing data warehouse. And again, from business logic, it's very rigid. So you can see it's a great platform, but it doesn't change. It's very difficult to change, and it's slow to change. So what's happened, and as a result of this current wave of analytical tools, is the advent of a bit more of the ad hoc model. And this is predominantly because IT can't keep up the demands of the business units, so the business units have started building their own ad hoc reporting solutions. And in almost all cases, this is usually outside of the governance of the IT department. So what the ad hoc model looks like is you have that same source data, but instead of the integration, the data repository, and the semantic layer being centralized into one definition of the data, every single report, every single query, pivot table, ad hoc analysis, they're building up their data model from scratch. They're putting in their business logic into each individual report. So that data model is being replicated in my particular visual up to 9 different times. That same potential KPI definition, that same business logic could be replicated 9 different times within that environment. So if we look at the benefits on the ad hoc model, if you look down, for the most part, it's dynamic. I can bring in new data sources, I can bring in new business logic, I could get very specific, purpose-specific reporting, very dynamic, very purposeful. But if I look on the limitations, it's pretty much the opposite of the traditional analytics. So there's no central data modeling by report, so there's no centralized integration of the data. On the reporting side, we're getting into this kind of Excel hell scenario where you get this risk of inconsistent reporting. And anybody that does reporting needs a really deep knowledge of the source data. Because it hasn't been modeled for them, they need that deep knowledge of source data. And my experience in the business, they don't always have that. And it gets a little bit of a little knowledge can be dangerous situation where there's a certain way to join the tables, interpret the data, you need to apply this filter, and they don't always know that. And so that deep knowledge of the source data doesn't always exist, but that doesn't stop them from moving forward and creating those reports. The business logic is replicating each report, so you have that huge risk of inconsistent business logic. So when that KPI does change or that business rule does change, you need to go out and find those 9 different reports or those 9 different business models where that KPI was defined and making sure that that gets updated. And when you're in an ad hoc environment, you have no idea what's out there. We recently are doing a migration from on-premise to Azure for a client, and we're basically saying, well, how is this data being used, where it's being used? It's like, well, we just gave them access to the cube. There's 1,000 Excel spreadsheets out there, but we don't know what they're doing or what data they're pulling or anything else. And they're fortunate because they have a centralized data model, so they know once they change the centralized model, it'll cascade out to all of those. But if you've got 1,000 individual Excel reports and you don't know who's using them, what the business logic is, but you know business decisions being made off of that, that risk of that distributed data becomes much higher. And then security, you can manage the row-level security and add security rights, but it's not a centralized security model. So you could be giving, on one report, giving people more data than they should be granted access to, or restricting data when you don't necessarily need to. So what I want to do is I'm going to kind of go through the three V's and show how we kind of deal with that. So the one that's probably dearest to my heart, and I think the hardest one to change, is that velocity of change. So in an ideal world, both of these models are combined. So you'd have the strong data governance and security model of the traditional data warehouse, but you'd have all the dynamic characteristics of the ad hoc model. So this is really suitable for that velocity challenge that we talked about earlier. So I don't know if the approach I'm giving you now would have worked as well, 3 or 4 years ago, but the recent enhancements to SQL Server analysis services, as well as the introduction of Power BI, within the Microsoft stack anyways, have really allowed us to put together what I would kind of call a hybrid approach. So the way this works, and to me this is what I called the foundation of my modern analytics. What we do is we look at data from a maturity point of view. So starting on the far right, you have your ad hoc data. So this is data that's still being generated within the business. And it's nice to say, okay, we're not going to allow that to happen. It's going to happen. So what you need to do is you need to create a framework around managing that ad hoc data. And then the next level is where you've brought that into your semantic layer. So that now you're working with this data directly. It's within IT control, but it's gone through a semantic layer. So this semantic layer will give you that single version of the truth. And that's kind of the second level of maturity of a data as it kind of works its way through the evolution of the company. And then the last one is your enterprise data warehouse. This is your fully managed data. It's going to go through a full integration layer. You're going to have your business logic. But you'll notice we have different data sources at all 3 levels. We have different integration logic at all 3 levels. And we have different business logic at all 3 levels. Not for the same data point, but for different data points. But there is that aspect of each of those tools in each of those 3 levels. So how do we manage this data if we have this structure? And before I get to that, so the one thing to note is when you're at the presentation layer, you have access to all 3 sets of that data. You have access to the enterprise data warehouse data, You have access to the data that's in your semantic layer, or SSAS, and you have access to data that's within the ad hoc environment. So your business users have the power, have access to all three sets of this data, which I think will meet their requirements to access the data. But how do we manage this, and how does this work through the system so that we maintain this IT control and data governance? So I view it as a three-stage approach, right? So to the maintenance and adoption of your data sources, new business logic, new integration logic. So the first one is the ad hoc layer, which is the identification of that ad hoc data source or logic. So that you can turn around in days. That gets done very quickly. That's, you know, you're doing that in Power BI, you're doing that in Excel, or you're actually writing a stored procedure or something, but that can be done very quickly. Within a matter of days, you can get that data turned around, and with the modern visualization tools, that works great. The next step is once something no longer becomes purely ad hoc and it really becomes a source of data that's being relied upon within corporate reporting, you know, as part of your financial package, as part of your weekly status report, it becomes official data. Then the enterprise needs to adopt that data and that new data source and that data logic. But it needs to be done in a fairly rapid point of view. You need to be able to adopt that within weeks. You know, so if you put it in ad hoc in last month's financial reporting package and they say, yeah, we really, really like this, we want to see this every single month, you want to be able to have that in place for next month end. You don't want to tell them, okay, you need to go through this 27-step process you did last time to create this data source for the next 6 months while we figure out how to get that into the enterprise data warehouse. We need to find a way to get that into weeks. So that's really kind of the adoption of the new data sources or logic. The final stage is the final enterprise integration of the new data source into the enterprise data warehouse. And depending on the system, but you know, that can typically take months. I don't know of any data warehouse build, even iterations, where it's typically not taking 2 to 3 months from the beginning of requirements to getting through final UAT and deployment to production. And that's assuming that you actually can start the requirements. If you're 2 months into, or a month into that cycle, and you have to wait for the next cycle to get your requirements in, this could go 4, 5, 6 months out. So how does this work? So when you identify a new data source, so the new data source initially adopt the ad hoc structure. So whether mashing together with enterprise data in a tool such as Power BI, with the new data sources, but that's all done by the business typically. So the business or IT can do it, but typically that occurs within the business. And so what you see here on this new Excel file here, we brought this into ad hoc, we've mashed it together with some enterprise data, and we've created some sort of ad hoc analysis up in this area. Define your own business logic, integration logic up here. What you want to do on a periodic basis is you want to manage those ad hoc data sources. So the nice thing about Power BI, you have access to all the data sources that are published out there if you're using Power BI as one of your primary ad hoc tools. You can go in there and say, okay, here's some ad hoc data, here's some new data source, ad hoc data sources that aren't governed by IT. Be able to create an inventory of those. And what you should be doing on a periodic basis is determine whether that ad hoc data source is truly ad hoc and should be retired, or whether this is something that's being used and part of your corporate reporting that allows you, that you now want to formalize it within the IT organization. So that becomes a decision point periodically against your ad hoc data sources. But the initial build, again, can be done within days. The next is kind of the enterprise adoption. So this is where IT takes formal ownership of the data. So by moving it into the semantic layer first, you can avoid a whole series of months of design and development. You can typically, I find, you know, if you've got an established semantic model in SSAS, to do an enhancement, even to work it through production and everything else, this can be done in a period of weeks. By also moving into this area, you're not leaving a whole bunch of ad hoc. You want that ad hoc to be a small slice on the top of your data. You want 95% of your data coming from either your managed data sources or your direct data sources. Your ad hoc should be a very small percentage of it. So to incorporate the new data model into the semantic layer, what you want to do is you do want to do a certain amount of data modeling and make sure that you're trying to replicate as the output of the semantic layer the final structure that you anticipate incorporating within the data warehouse to as much as possible. And what this will mean that once you move it from ad hoc into the semantic layer, you're going to replumb all those previous ad hoc reports and no longer using their ad hoc data sources, but to use a corporate data source. Once they've done that plumbing, once you eventually move that data potentially from the semantic layer to the enterprise data warehouse, there'll be no more impact on the reporting. Okay? And then the final stage is enterprise integration. So one of the things about this one is you don't necessarily need to move everything into an enterprise data warehouse. Enterprise data warehouse is really when you require a lot of integration between different data sources. You'll have a lot of complex transformations. You want to do delta processing, long to manage performance. But if you're just pulling in, statistics off of a website on Statistics Canada, and you're just comparing that against something else or weather data, there's no necessity in the modern environment to push that through an enterprise data warehouse. You can bring that directly into the semantic model and take advantage of that data. There's no value added necessarily by pushing that down to the enterprise data warehouse. So if you do want to incorporate it into the enterprise data warehouse, then you need to go through your standard ETL data quality processes. You need to incorporate the new data sources, business logic. And if you've done this correctly and you're able to model that semantic model up front initially, then once you change the data source and the semantic model from that ad hoc source to the enterprise data warehouse, you should not have any effect on the existing reporting or analysis. So from a front user perspective, that should be completely transparent to them. They should not really know and or need to care whether it's something that exists only in the semantic layer or whether it also exists in the data warehouse as well. Okay. All right, so how does this work around kind of data governance? Like, so you have this ad hoc environment. How do you manage, the data governance and security around that? So my vision is it really converges at the semantic layer. The nice thing about the semantic layer is it provides that integrated data model. So you don't really need to know anything about the source systems in terms of how they relate to each other, how the data integrates, how KPIs are defined. That's all taken care of you. Your KPIs are centralized, and your security model. So whether you have access to this data or don't have access to data, you're defined that at one centralized place, and that cascades out to everything else. So whether that's just access to the data at all, or whether it's a slice of the data through row-level security, doesn't matter. And then your presentation tool can be whatever you want. So, one of the things that we go in, and we quite often go in to talk to people about Power BI, and they say, we've got Tableau, we like it, we've got ClickView, we like it, we built it up. The semantic layer with SSAS is kind of heterogeneous in terms of the presentation tools. They can all connect into it, they all interact with it in the same way, in the sense that they're getting all the benefits of the semantic layer in terms of that integrated data model, centralized security, centralized KPIs. So if we take a look at how the semantic layer comes in, is from a development perspective, that ad hoc presentation layer is probably a combination of your IT and business. In terms of the actual build and ownership of data assets, that starts really at the semantic layer in a lot of cases and goes through your data repository, integration layer, etc. But in terms of data ownership, what we want to do is, I don't necessarily, you will get business users involved in the generation of the data repository and everything else, but since that's not necessarily the single source of truth or all the data that's coming into your semantic layer, and since you're also defining security and everything else, I really see the semantic layer as where that business approval and that security approval comes in. So nothing gets presented in the semantic layer as that official corporate data that everybody can consume unless it's gone through an approval process at the data ownership level and at the security level. So everything goes into that level. So if it's not right at the semantic layer, it could be something wrong with the integration layer, it could be something with the data repository layer. That's for IT to figure out. They need to figure out what's going on behind the scenes there. The business users really only care about what's coming out of that semantic layer and analysis services. It's IT's responsibility to figure out where that problem is, but to me, that's a single point of focus for the business as well. So it really converges at that semantic layer. The hard part about this is, so the conceptual part is really easy. The really difficult part about this is that it really requires heavy business involvement. So I see sponsorship of data really at the semantic model layer. So that semantic model could require an enterprise data warehouse to support it. It may not. But what you're supporting is semantic models. If you've got an existing enterprise data warehouse, you can use the semantic model to create different data mart focused semantic layers. But again, those need to be sponsored and by the business involvement. So what that means is they're responsible for defining requirements, they're responsible for validating the data, validating the business logic, they need to sign off and approve, and they need to be involved on an ongoing basis in terms of overall enhancements, fixes, maintaining that. The business should have that level of involvement and ownership. Similarly, on the security side, they need to bring in their security requirements. They need to validate the security. They need to sign off that the security is okay. And typically, when you're defining security at these levels, you typically are dealing with AD groups and not individual AD members. But changes to AD members or changes to the AD groups related to this semantic model security needs to have that ongoing maintenance of security. So if somebody's going into an AD group that's accessing HR sensitive data through that semantic layer, then security needs to sign off on that. And sometimes the security office is a completely separate office, sometimes it's part of the business unit, so everybody needs to figure out what that balance is. But I think these two critical elements are necessity to really manage that data governance and security. We're all good? No questions? Okay. So, all right. So that's kind of the overall platform. So that's going to really help you with the velocity of change. You can see very quickly that the business gets access to data that they need, critical data they need within days, and that migration even into a formalized IT owned is still within a month, very quickly. And then, to the extent that you need to really build out that model, whether it's delta process, more complex transformation logic, that may mean you take it into the enterprise data warehouse. But the bottom line is the business is getting response from the IT department very quickly and getting their support of new data sources, new technology, new KPI definitions immediately. So what's not covered in here is obviously some of the processes and procedures that need to be implemented to kind of support these types of policies. So the next V, or the next principle of the modern data analytics, is the volume of data. So the traditional approach to dealing with volumes of data, first of all, was typically hosted on premise. So you needed some sort of advanced knowledge of the nature and size of the data you'll be storing and analyzing. And so not only did you have to kind of analyze that, but you had to make hardware and software purchases based on that uncertain future. So typically one of two things happen. You either over-provision and you're paying for a whole bunch of capacity or a whole bunch of servers that you're not utilizing at full capacity, or worst case scenario, it's underperformed, you end up with an application that's slow performing, you need to buy new hardware to re-platform it, or you're running out of memory space and you're always kind of looking for more memory, more RAM. All of those are kind of the traditional way that we used to deal with that volume. So, so cloud architectures, I think, have really solved that problem. I mean, VMs went to a certain extent to do that, but even if you're dealing with VMs internally, you still have to make that commitment in terms of, how many VM servers do I need to buy, how much memory do I need to buy to support all these VM environments, whatever else. The advantage is you're getting a lot more optimization about the individual server instances within the VM, but you're still facing those hardware and software requirements and licensing issues. Cloud architectures and pure cloud architectures, because there's different types of cloud architectures. There's a lot of people that refer to cloud architectures that are actually still just hosting you and you're working on dedicated servers. I'm talking more like the Azure, where you're still looking at purely flexible environment where you can literally, with a slide of a dial, turn around and increase the size of your Azure instance. So it gives the ability to scale up when needed. So if you have peak processing times or analysis times, so going back to the corporate data, if you're, the first week of the month, you've got, everybody's hitting the reports for the first 7 days of the month, and then, your volume drops off by 90% because everybody's got the previous month results and they're now moving forward. You can scale that stuff up for the first week, 3 or 4 times capacity, everybody's getting really quick response, and then drop it down at the end of the day, or at the end of the 7 days, and drop it down to 25% of that volume, and not pay for those services when you're not using that capacity. And also when you're actually analyzing data. So, shut it down from 8 p.m. till 8 a.m. Why pay for all that capacity when everybody's sleeping, or that volume? It also scales up for your volume growth. So most of these, you don't even have to say you need more data. It just automatically expands, and you only pay for the data that you need. That gives you the ability to grow up. And like I said, the ability to scale down when it's not in use. And so, we find one of the things that really helps in terms of a cost-saving perspective is if you've got a traditional EDW environment where you're maintaining 3 different platforms, you got your dev, test, prod, that's 3 hardware boxes, that's 3 sets of commitments. In an Azure or cloud environment, the dev environment you'll bring up when you're actually doing development, but when you're not doing development, you can take it down. Most importantly, your test environments, which usually probably about 10% of your overall project size, you only need to bring those environments up for when that's occurring. And most cloud architecture, you only pay for what you're using. So it's either overall capacity in terms of size of processors or size of hard drives you're using, or depending if it's more like streaming services or IoT devices, you're really based on the number of transactions you're going through. So, you may say, okay, we got this new campaign going, we think we can get 1,000 transactions a day, but we think if it goes really well, we'll have 1 million in 6 months. Under the old model, you would have had to buy hardware and capacity to support that 1 million. Under cloud architecture, you just pay for that 1,000 until you need 2,000, until you need 10,000, until you need 100,000, until you need 1 million. You scale it up as it is, and that way the capital commitment related to these projects is much better. And there is definitely ways to fully automate this. So you can do this through PowerShell scripts, or you can manually do it through the Azure portal. Okay. I was going to try to go in and do some demonstrations of this right now, but we're running a little bit close on time for me to finish up on time. So I'm just going to go through that. But it's literally as easy as sliding a dial across to increase capacity memory and scale it back down when you need to. You can even just have it tell to shut down the service every night when you want it to. So those are things that through the Azure portal are very easy to take a look at. Okay. So how do you get there? So I talked about leveraging your existing investments. So if you do have your traditional enterprise data warehouse structure on-premise, how can you migrate that to Azure so that you're getting to 100% platform as a service environment by leveraging your existing? So your data sources, the good thing about data sources, you don't need to do anything with them. So if they're on-premise or wherever they are, any existing ones, when you move on to Azure, they can stay exactly where they are. You don't need to do anything other than installing the data gateway, the Azure Data Gateway, which will continue to talk to those services on the same basis that you talked to them before. Because this, excuse me, because the gateway is behind your firewall, the connection strings, the user authentication will be exactly the same as it was under the old environment. For your actual enterprise data warehouse, which typically is a SQL on-premise environment, that you can migrate to Azure and basically in an as-is environment onto Azure SQL. And they're actually releasing right now a new instance called Managed Instances with SQL, which will be exactly identical to on-premise. So it will still include jobs, it will include your SSIS catalogs, all that will be included in terms of that managed instance, but you're still dealing in a PaaS service. SSIS is now supported on Azure, so it's run through Azure Data Factory, but you're able to leverage all your existing SSIS packages exactly the same way they worked before. Maybe a little bit of work managing new data connections as you move your destination databases across, but you can move the code over as is, and it'll work exactly the same way in the PaaS instance as it would exist on premise. And finally, the semantic layer of SSAS, it'll migrate over to as is to Azure SQL Server Analysis Service and continue to work exactly the same way as it does today. So what you're able to do very quickly is to migrate all those data sources over, so there's absolutely no change at all. So In terms of the data sources, on-premise is the same way. The on-premise gateway is extremely secure, acts as a bridge between your Azure and your on-premise data sources. There's very limited or no changes to your firewall because it's all outbound traffic, so you don't have to punch a bunch of holes in, and you don't have to change that application source security. Migrating databases, Microsoft has put together a whole series of tools that will help you migrate your databases. So one of them is called the Data Migration Assistance. So it allows you to not only upgrade onto Azure and move your data, but it'll actually upgrade if you're on an older version of 2012. It'll allow you to upgrade your SQL version at the time you're migrating. It'll go through compatibility checks, identify store procedures or functions that may not be compatible, so you can kind of focus just on that 1% that you might need to tweak, but the other 99% is done automatically. So you can use automated tools, you can use PowerShell scripts to do a lot of this stuff. If you're not on Microsoft as a platform, there are tools available for Oracle, DB2, and MySQL as well in that environment. As far as SSIS and SSAS, it's really the same process as you currently have today. So typically you would deploy from Visual Studio for both your SSIS and SSAS solutions, and it's really no difficult in changing the destination target. If for some reason you don't have the Visual Studio projects available for your SSIS or SSAS, Visual Studio has the ability to reverse engineer those models if needed and pull it through. So I won't spend a lot of time on that, but it's really, even the development environment, everything is identical between your on-premise and Azure as well. So they continue to use the Visual Studio tools, etc. So the final result is you basically took that hybrid, you've taken your on-premise model and you brought it onto Azure with minimal migration effort. You're now in a full PaaS offering, and the advantage within these PaaS instances is that ability to volume scale up and scale down very quickly. But you get some additional benefits with PaaS. Your backups and geo-replication are fully automated. The services are automatically updated and patched. You can turn the services or pause them off when not in use. Then talk about scaling up and scaling down. And you have no fixed hardware or software costs. You pay for what you use. If the service you're not using that database, you're not using that data mart anymore, then delete it. You're done. You don't pay for it anymore. You're not committed to that hardware cost. And like I said, you can scale up or scale down as necessary. And typically, most of the analysis we've done, if we take a look at the overall total cost of ownership of an on-premise versus moving to Azure, is a much lower total cost of ownership. Okay. All right. So the last aspect I wanted to kind of talk about was the variety of data sources and how, now that we've kind of taken our existing traditional enterprise data warehouse, we've moved it up into the cloud to deal with the volume. We've implemented the Modern Analytics Foundation to deal with the velocity of change of data, to be able to integrate it. Now that we have this platform, we have all the scalability, how do we deal with all these variety of data sources that are coming into our organization? So, some of the things that we're finding our clients are starting to deal with, streaming data, integrating multiple data sources, analyzing IoT devices, integrating unstructured data into their data warehouse, dealing with a lot of external users, in terms of giving your external users more access to your data, doing more advanced analytics, whether it's predictive analytics, detecting anomalies, sentiment analysis when it comes to streaming social data, all of those types of things. So the Modern Analytics Foundation still exists. What it is that we've gone from the ability to consume just a whole bunch of limited on-premise data sources that are coming from like SQL and CSVs and Excel files. We're now able to start consuming all of these tools across here, whether it's ERP data in your hosted Dynamics 365, to data lake data, IoT data, machine learning algorithms and outputs, social data, anything on the web, and good old Excel, which still seems to be a data source for so many different applications. So we just wanted to kind of show you how, with something like integrating multiple source systems, can leverage a lot of these different tools, but still stay within the framework of the Modern Analytics platform. So what we're going to do is we have 3 different social media sources. And what we're looking for is kind of the overall sentiment around this. So we got Twitter data, we've got Facebook data, and we've got surveys that we've conducted. We want to make sure we get sentiment across all of those, but we also want to report across all of them in an integrated environment. So the way I did it within the Azure platform is Microsoft has some solution templates for both Twitter and Facebook. So what I did, they're called the branding campaign management. Twitter is the actual solution itself. And what that did with about 15 minutes of clicking through prompt screens, mostly just saying, here's my subscription, here's my email address, those types of things, and what Twitter handles we want to bring in. I was able to create a Twitter feed that pulls data in, goes through streaming, goes through sentiment analysis, and populates the data into a SQL database. Did the same thing with Facebook with the end result of dumping into a SQL database. So I used the standard out-of-the-box tools. You could also do the same thing with building it up from scratch. So using Azure core components, so using event hubs, Azure streaming and cognitive services instead of using a pre-configured one. Either one will ultimately end in the same option. The advantage of doing it individually is you could have the output not necessarily be an Azure SQL Server, which is a requirement of the solution templates. You could have it go to Power BI, to Azure Data Lake, blob storage, anywhere you wanted to, if you configure it a bit more manually. But moving on with the actual case study, so the last area we wanted to do is I wanted to ingest survey data. So what I did here, because this is just a whole series of individual CSV files, I just wanted to manually upload those. I just manually upload those to our data store, because that's where, until we know what we want to do with data and it's unstructured, we are putting everything into a data lake until we're ready to consume that data. So our next step was to figure out how do we integrate and map the sentiment data from multiple sources into kind of one perspective. So from Facebook, we looked at the reactions, so happy face, smiley face, angry face. We actually looked at that, applied sentiment analysis to the comments, we applied sentiment analysis to the tweets, and our surveys had a rating of 1 to 10. So what we were able to do is we actually used a tool called Azure Data Factory. So if you're used to SSIS and the control panel, how it manages all your integration pieces, Azure Data Factory is the orchestration tool within Azure. So it kind of acts as the backbone for all your ETL and data movement. And it has the ability to call SSIS, but also has the ability to call Hadoop. HD Insight has the ability to call uSQL. It can call a whole variety of tools that allow you to integrate all that data together. So what we did is we created one Azure Data Factory pipeline that combined the sentiment from the Facebook database and the Twitter, and those pipelines created a normalized set of data in the data factory for comments and reactions. So all the files at this layer all had the same structure at this level. So it was a little bit, this was a simple SQL query to, simple SQL statement to summarize my comments, combining 4 or 5 tables into a flat file. Same with reactions, same with comments. In the case of surveys, this was actually dumped on the data lake, so we actually just use another pipeline just to take that same data and just have it conformed into the same structure as the Azure and Twitter data. And then from a reporting point of view, by connecting in through analysis services or through Power BI, we're able to connect into these at the folder level. So as we add this data in, so when I initially did it, I just had the Facebook data, created the connection, consumed the data. And then when I added the Twitter data in, all I needed is refresh the data. I didn't need to replumb anything else underneath. I just did the underlying thing. And again, when I added surveys in there, all I had to do is land the data into this folder. The ETL, it's not an ETL process, it's really just a data read process from my as a source system. Because it's Azure Data Lake, could handle the structure of that. So this is a way that we've kind of, through a very simple integration process, able to integrate these sets of data. We didn't need to put it through a formal EDW, because you could have, but I probably did this whole thing in probably a day's effort. You'd have trouble doing the design document for the SSIS in 2 or 3 days for this. So the modern tools that are existing within Azure allow you to consume and normalize and be able to consume this data in a whole bunch of different ways that you did before. And not all of them necessarily, like I said, need to go through that enterprise data warehouse. And so what this looks like from the overall Modern Analytics platform is my surveys, which are actually CSVs, but I couldn't find a CSV icon, so I used Excel. So this is actually using USQL to kind of go into the Azure Data Lake. My social media, which is coming through as a direct feed, is going in the Azure Data Lake, and both of these are being consumed into my enterprise semantic layer. But it didn't necessarily start this way. When we first did this, the Facebook and social, we were actually using them as independent ad hoc sources. So when I got that managed solution, it actually gave me Power BI reports. So I could go in and look at Facebook by itself. I could look at Twitter by itself. I could look at my surveys by itself. But by moving it from that ad hoc environment to that direct environment, we got that level of integration that we were looking for within those two environments. And what was kind of tying that all together from a ETL integration perspective was the Azure Data Factory. All right. So I have 3 minutes left. I can kind of go through the slides, or if there's any questions out there, it seems like.
No questions yet, so maybe just continue along with the slides, and if they do pop up, we can answer them.
Okay. I don't have anywhere to go right away either. So, so we got so it basically does this data integration at scale, manages your pipeline. It has full ETL capabilities or ELT capabilities, supports SSIS, has all kinds of native data connectors that'll help you. And it's really that orchestration piece that's really important about the Azure Data Factory in terms of tying all your integrations together. And so that ties all your integration layers together. If you kind of move up one layer further into the Azure portal, this also gives you the ability to manage everything that's going on within the overall portal. So not only are you managing your Azure Data Factory, but you can manage your SQL instances, your data lake store. Everything kind of goes through this main portal. So you can view and manage all your applications. So the application I built when I was doing the workshop to support this webinar, these are all the different services. So I got my Data Factory services here. I got my SQL Server, all the individual databases, which I can access immediately. I got my SSAS instance. I got my Data Lake Analytics, my Data Lake Store. So really from one dashboard, I'm able to access all the different services that I have. You can control full access. And billing centralized as well. So instead of trying to figure out where the billing's coming in, you get one integrated bill. You can break it down by individual subscriptions to the level of detail that you want if you need to charge out. But everything kind of shows up in one area. You can see all your services, all your consumption in one area, which makes it from a management perspective much better. You can add alerts, etc. So if you're trying to make sure, if you're worried about the volume of something going up and you're worried about the cost related to that, you can put the necessary alerts in there. All the events, audit logs are all centralized, and if you want to extend this out through APIs, there's lots of APIs available to support that as well. Okay, so if I kind of summarize, the Modern Analytics platform, the structure of ad hoc to direct for manage, is really how you're managing the velocity of data. So the highest velocity is at the ad hoc, medium velocity is at the semantic layer, and then kind of low velocity is your enterprise data warehouse. All layers of Azure support that volume issue, whether it's the presentation layer, the semantic layer, integration, source databases. Azure handles volume there. And you can see from the variety of sources here that Azure can support any variety of data sources that you might have being pulled into the system. Okay. So thank you very much for your time. Just thought I'd throw a couple slides up just to show you kind of some of the other DSI services. So I'm hoping I'll get at least one question out of the deal, but no, everybody's quiet. So I hope everybody got a little bit out of this, and obviously, if you want to understand a little bit more about this, we're more than willing to actually get on a call with you or come down and do a little bit of workshopping to figure out where you are today, where you'd like to go tomorrow, and figure out how some of these concepts may apply or how SQL and Azure can help you on that path to a modern analytics platform.
Awesome. Okay, well, thanks so much, David. So I will follow up with everyone. You'll get a recording of this webinar. I'll also give you my email as well as David's email, and feel free to email us with questions, comments, or concerns. And like David said, we'd love to have a conversation and see how we can help you, and we hope you found this webinar valuable. Thanks, guys.